Hello everyone, we are Gabdrakhmanov team and we solved the problem answer prediction from the Kaggle. And what's the problem is, in the traditional offline education system, teachers had the opportunity to see each student and could sense its potential. They knew their strengths and weaknesses, and the lessons they taught were based on students' ability. This is mainly why students pass successful subjects and how education goes effectively. However, in the post-pandemic world, with the transition to online education, such ability to evaluate students and reorient education approach had been lost. And it can be seen that such loss of personalized learning had a dramatic influence on the education quality, which makes the creation of the modeling of student knowledge over time to be important. So our goal is to build accurate prediction of how students will perform on future interactions, and it helps teachers understand the students' potential in the future. And the data we used is RIS-IDNET data from the Kaggle. So here you can see just the representation of how we load the data and how we split them. And I want to mention that huge amount of data do not allow us to perform work in such a usual environment, and we used Google Cloud Platform with Google BigQuery. Here you can see the preparation of our data set, and the first what I want to mention is that we do not use categorical variables. Secondly, after feature engineering, we dropped all IDs. Here you can see how that due to the lots of amount of data, we dropped NAs, which is just about the 5% of the total size of the data set. And let's just move on to the feature engineering. And here you can see the list of new features, just 5. And the first one is mean task container time, which is just the average time users spend on each container, each task with the questions. And the next feature is mean user accuracy, which is the average distribution of the correct answer per user. And here you can see the distribution on the slide. The next feature is questions answered, which is just the number of questions answered for each use. And the next feature is mean accuracy. It's just the distribution of the correct answers to the questions. And the next feature is questions ask feature, which is the question appearance frequency. And you can see the distribution on the slide. Let's just move on to the just data set contents. Here you can see the correlation matrix and some distributions of initial features such as user ID distribution. And here you can see some top 10 most active users here, and top 10 popular content ID here, and just top 10 tasks. It's represented here. And let's just move on. And here you can see the users correct how user the distribution of correct answers. And we see that mainly about 2% of activities are just lectures, and we drop them. We just exclude them from answers analysis. And we can see that mainly the users saw the explanation and the correct answer after answering the previous set of questions, which is represented here. And here we can see that users tend to answer correctly often and see explanation after answering the previous questions bundle, which is represented here. And let's just move on to the additional data processing. Since we have lots of data, we just decided to filter some rows, and look for, as a first, we filtered time-step fields because so many people passed the test in short time, and we just removed them for a more balanced distribution. And we just did a bit the same with the user ID. Here we see the distribution of the number of questions that were answered for each user. We can see that most often people answer a small amount of questions, which is represented here. So here we can see that active users answered much better than the new users, and that's why we just dropped the new users and used the old one. You can see their distributions here. So and we just we will do additional filtering by content type ID fields, as I told previously. So in our work, we used 3 models, and first of them is the Gaussian MB. Here we used stratified key folder cross validator, and there each set contains approximately the same percentage of samples of each target class as the set. And here we use naive Bayesian classifier, and this classifier works fast, and we have lots of data. That's why it's just a bit convenient for us to use. And here you can see the accuracy of that model. Let's just move on to the next. Our model is logistic regression. We used grid search CV and, as I said before, a logistic regression model. Because our goal is to increase the quality of the model by using some different nature classifiers. So we just used a different one, and the estimation of the quality of prediction was a bit better than the previous one, which is represented here. And also we used cut-boost classifier model. Here we go with the default parameters, as they provide a real good baseline almost all the time. And the only thing we'd like to specify here is a custom loss parameter, as this would give us an ability to see what's going on in terms of this competition metric accuracy, as well as to be able just to watch for log loss, as it would be more smooth on the data set of such size. And the total score of accuracy is here, which is better than the previous 2 models. And just to prove our model, we used cross-validation procedure, which is represented here. And you can see that it's like the same as we obtained before. So here we just move to the data analysis part, and here you can see the ROC curve, and the ROC curve shows the model's ability to distinguish between classes, and the better is the classifier, the higher is the ROC curve. And it's plotted with TPR, true positive rate, and on the y-axis against the FPR, which is the false positive rate. You can see it here. And for our model, we have received a sufficiently high ROC curve. So let's just move on. And here you can see all the results of all accuracies. You can just see that the previous one is better than the last is better than the previous one. And I'm sorry, here you can see the probability of the probability which we obtained for users answered correctly probability. So here you can see the feature importance and feature importance. The generated, and here we can see that generated mean accuracy and mean user accuracy got the best results because they are on the distribution of answers to questions, and the other three features and columns have almost the same score, and the column prior question had explanation is expected received a low score because almost all questions had an explanation. And also it can be noted that the last generated feature log prediction staking didn't produce any results, since the prediction obtained in the log loss with a low weight. So what's our conclusion? To sum up, the model built to predict whether the student will be able to cope with the task, just the probability of the task handling by student, and the application of the model will be extremely useful in practice in the real world applications, because we can use it for course planning for a specific group of students, and for change assignments for better students, as we will see that their probability to pass this task is higher than the average students, and we just can increase learning effectiveness. So this is all that we did. Thank you for your attention. How can I stop the recording? Sorry, someone help me.